Have you ever tried to imagine everything that exists but cannot be seen? Not just the stars twinkling overhead or the planets that move silently through the sky, but the hidden forces that shape the cosmos itself? Try for a moment to picture a universe where most of what exists is invisible, slipping past our eyes, undetectable to our senses, yet holding galaxies together and pulling space apart. It is one of those thoughts that makes you feel small but also deeply curious. If we can only see a tiny fraction of reality, what are we missing? Picture yourself standing outside on a perfectly still night. The air is cool against your skin, and above you, the sky stretches wide and endless. The stars seem to shimmer like dust scattered across black velvet. To your eyes, this feels like the whole story of the universe. But it is not. Those points of light are only the surface. Beneath that visible layer lies a hidden architecture, a framework of invisible matter and forces without which the stars themselves could not exist. Tonight, we are going to drift into that mystery together. We will begin exploring the invisible universe, the unseen foundations of reality that have puzzled astronomers and philosophers for generations. Some of what you hear may sound strange, perhaps even impossible, but that is the nature of wonder. The universe does not fit neatly into what our senses can hold. It stretches beyond sight, beyond touch, and beyond imagination. I am curious to know where you are listening from tonight. Perhaps you are lying in bed, letting the weight of the day slip away, or maybe you are sitting quietly in a dim room, allowing your thoughts to wander. However you arrived here, you are welcome. These words are here not only to spark curiosity, but also to carry you into rest. You do not need to hold every detail. If you drift into sleep as we go deeper, that is perfectly fine, and if these gentle explorations bring you comfort, I would be grateful if you considered subscribing so that others may find their way here too. Now, let us begin. When we look at the universe with our eyes, even aided by telescopes, we are seeing only the visible part, the light from stars, the glow of galaxies, the faint traces of gas clouds. Yet scientists discovered something troubling. The way galaxies move, the way they spin, the way clusters of galaxies hold together, does not make sense if the only matter in the universe is what we can see. There must be more, something invisible adding weight and pulling with gravity. Without it, galaxies would fly apart, their stars scattering into space. This invisible substance is called dark matter. It does not shine or reflect. It does not emit heat or light. It cannot be seen directly, yet its presence is revealed by its effects. It holds galaxies together. It shapes the cosmic web, that vast network of filaments and clusters stretching across the universe. Without dark matter, the universe as we know it would not exist. Imagine a great invisible scaffolding like a vast cosmic skeleton. On this skeleton, galaxies are strung like beads of light. Stars and planets form where dark matter provides the structure. It is as though the visible universe is a glowing mist clinging to an unseen framework. We cannot touch it, we cannot see it, but we know it is there because without it, everything would fall apart. The idea that most of the universe is invisible is humbling. For centuries, humans believed that what we saw was the whole story. But now we know that what is visible is only a fraction. Nearly all of the mass of the cosmos is hidden. Dark matter outweighs normal matter many times over. That means the atoms that make up stars, planets, oceans, trees, and even our bodies are only a small portion of what exists. Most of the universe is made of something else, something we still do not understand. There is another invisible force as well, one even stranger. Not only is the universe expanding, it is expanding faster and faster. Something is driving this acceleration, something that pushes galaxies apart, stretching the fabric of space itself. This mysterious force is called dark energy, and it makes up the largest share of the cosmos. It is everywhere, woven into the very emptiness of space, quietly pulling everything outward. If dark matter holds the universe together, dark energy pushes it apart. Pause for a moment and imagine this balance. On one side, dark matter pulling galaxies inward, holding them in clusters, shaping the great web of structure. On the other side, dark energy pushing outward, accelerating expansion, pulling space itself wider with every passing second. The universe is a silent tug-of-war between forces we cannot see, forces that determine its fate. When you think of the invisible universe in this way, it becomes almost poetic. The stars we admire are like sparks on the surface of a vast ocean. Beneath them lies the deep water of dark matter and dark energy, unseen but carrying everything. We float in that ocean, unaware most of the time, but completely dependent on it. Without it, there would be no galaxies, no stars, no planets, no life. Beyond these invisible forces are particles even stranger. Neutrinos, for example, pass through your body by the trillions every second. They barely interact with matter at all. They slip through Earth as though it were transparent. You do not feel them, yet they are there, messengers from the nuclear fires of stars. They are part of the invisible universe, moving silently through us, reminding us that even our own bodies are open to the cosmos. Then there is the faint afterglow of the Big Bang, the cosmic microwave background. It fills the universe, a gentle radiation that hums quietly across space. It is invisible to the eye, yet with special instruments we can detect it. It is the whisper of creation, the light from when the universe was young. Every corner of space is bathed in it, a reminder of beginnings hidden beyond sight. So as you lie here tonight, remember this. The universe is not just what you see. It is not only the stars overhead or the planets in the sky. It is built on invisible matter, driven by invisible energy, filled with invisible particles and ancient light. What you can see is beautiful, but it is only a glimpse. The true universe is deeper, stranger, and far larger than our senses can hold. And perhaps that is the lesson of the invisible universe, that we should not trust only what we see, that reality is richer than sight, that behind the surface of things there is always more. More to discover, more to wonder at, more to imagine. As you rest, let that thought soothe you. The universe is carrying you, not only with the light you can see, but with the invisible fabric that surrounds you. You are part of both the seen and the unseen, woven into the same cosmic mystery. What lies beyond your sight is not emptiness. It is the very foundation of everything. When we speak about the invisible universe, one of the first mysteries we must face is dark matter. It sounds like something from a story, but it is as real as the stars in the sky. Without it, galaxies would not exist. Without it, you and I would not be here. It is a strange thought that the most important substance in the cosmos is something we cannot see, cannot touch, and cannot even identify with certainty. Yet its presence is undeniable. Dark matter reveals itself through gravity. When astronomers measured the way galaxies spin, they expected to see stars near the edges moving slowly, pulled gently by the mass of the galaxy. Instead, they found stars moving far too quickly, almost as if something invisible was pulling on them. If galaxies were made only of visible matter, those stars should have been flung outward into space, like stones spinning from a sling. But they stayed bound. The only explanation was that something unseen was holding them in place. That something is what we now call dark matter. Picture a galaxy as a glowing spiral of stars, bright and beautiful. Around it, like a vast invisible halo, lies a cloud of dark matter. You cannot see it, but it outweighs the stars, gas, and dust combined. It is this hidden halo that gives the galaxy its strength, its gravity, its ability to hold itself together. Without it, the spiral would unravel. The stars you admire in the night sky owe their existence to something you cannot see. The same is true on larger scales. Galaxies are not scattered randomly through space. They gather into clusters, hundreds or thousands bound together. These clusters are held by gravity far stronger than visible matter alone could provide. Dark matter fills the gaps, stitching the galaxies together like threads in a cosmic web. Across billions of light years, these threads of dark matter create the structure of the universe. The galaxies we see are only beads of light strung along invisible strings. It is humbling to realize that we live inside this hidden web. The Milky Way itself sits within a halo of dark matter, part of a filament stretching across the cosmos. Our solar system, our planet, our lives are carried on a structure we cannot see. The invisible holds us as surely as the visible. But what exactly is dark matter? That is the question that remains unanswered. We know what it does, but we do not know what it is. Some think it is made of particles, unlike anything we know, passing through matter without interaction, ghost-like and silent. Others wonder if it is something even stranger, a sign that our understanding of gravity itself may be incomplete. Imagine for a moment particles drifting through you right now, trillions of them, without leaving a trace. If dark matter is made of such particles, then they are flowing not only around galaxies, but through Earth itself, through your very body. They are part of your world, even if you never feel them. It is a strange thought, but also a calming one. We are not only surrounded by the invisible universe, we are permeated by it. There is a quiet beauty in this mystery. For centuries, humanity believed that the stars and planets we saw were the fullness of the cosmos. Now we know they are only a fraction. The great balance of the universe rests on something unseen. Dark matter shapes the galaxies, builds the clusters, forms the cosmic web. It is the silent architect of the night sky. And yet, it is patient. It reveals itself only through its gravity, never through light. It does not shine, it does not burn, it does not glow. It is content to work unseen, to shape the stage while letting the stars take the spotlight. In that way, it teaches us something about the hidden nature of reality. Not everything that matters must be visible. Not everything that holds the world together must be seen. Close your eyes and picture yourself drifting through space. Around you are galaxies, spirals, and ellipses glowing like lanterns. But behind them, invisible to your eyes, lies a vast web of dark matter. You cannot see it, but you can feel its presence, like an unseen current holding everything in place. You are floating not only through stars, but through the invisible fabric that binds them. It is not emptiness. It is foundation. This hidden presence may never be fully explained. Scientists build instruments deep underground, shielded from light and noise, trying to catch even a whisper of dark matter particles. They watch the skies for signs of its effect. They imagine theories of what it might be. Yet for now, it remains beyond our reach. Perhaps one day, its nature will be revealed. Or perhaps it will remain a mystery, a reminder that the universe is larger than human knowing. And maybe that is enough. Maybe we do not need to see it to believe in it. We feel its pull every time we look at the stars, every time we trace the spiral of the Milky Way, every time we wonder at the galaxies far away. Dark matter is already part of our lives, whether or not we ever touch it. It holds us, carries us, and cradles the universe itself. The invisible universe is not empty. It is full, rich, and alive with forces and structures beyond sight. Dark matter is one of its first secrets, and even if we never unlock it, we can still marvel at its work. It is the silent partner of the stars, the quiet weight that gives shape to everything we see. As you let your thoughts wander tonight, remember this hidden presence. The galaxies you cannot see are held by halos of matter you cannot touch. The stars you admire are bound by forces you will never feel. And yet, they are real as the ground beneath you, as real as the air you breathe. Beyond sight lies structure. Beyond the visible lies the invisible. When we think of the forces that shape the universe, it is natural to imagine gravity pulling everything together. Dark matter adds weight and structure, holding galaxies in place. But there is another force, one that does the opposite. Instead of pulling inward, it pushes outward. It stretches the fabric of space itself, carrying galaxies away from each other at ever-increasing speeds. This force is called dark energy, and it is perhaps the most mysterious of all. For a long time, scientists assumed that the universe's expansion was slowing down. After all, gravity is everywhere, pulling everything together. It made sense to believe that over time, the pull of matter would slow the stretching of space. But when astronomers looked more carefully, they saw something astonishing. The expansion was not slowing. It was speeding up. The galaxies were not only drifting farther apart, they were racing away faster and faster. Something was driving this acceleration, something unseen, spread across the whole of space. This something was given a simple name, dark energy, though the name tells us very little. We do not know what it is. We only know what it does. It pushes, it stretches. It acts as a kind of pressure, woven into the fabric of space itself. Unlike dark matter, which gathers into halos and filaments, dark energy is everywhere, filling all of space equally. It does not clump or cluster, it expands. Imagine blowing up a balloon. As you add air, the surface stretches. Now imagine the balloon growing on its own, faster and faster, without any hand to hold it. That is what the universe is doing. Galaxies are carried along like spots on the surface, growing more distant as space stretches beneath them. The galaxies themselves are not moving through space. It is space that is expanding, carrying them like passengers on a river that is widening endlessly. This discovery changed everything. It meant that the ultimate fate of the universe is not collapse, but separation. In the far future, galaxies beyond our own cluster may drift so far away that their light will never reach us. The night sky will grow emptier. The stars will fade from view, not because they have vanished, but because space itself has carried them beyond our horizon. The universe is not only vast, it is becoming vaster with every passing moment. Dark energy dominates the cosmos. If you add up everything in existence, from stars to galaxies to dark matter, dark energy still outweighs them all. It makes up most of reality, yet we do not know its nature. Is it a property of space itself, an energy that arises simply from emptiness? Or is it something else, something deeper, a hint of laws we do not yet understand? The strangeness of dark energy is not just its strength, but its silence. It does not shine. It does not interact. It simply stretches the fabric of reality. You cannot feel it. You cannot detect it with your senses, yet it is everywhere, in this room, in the space between your eyes and the words you hear, in the distance between the earth and the moon. It is woven into the universe like an invisible tide. Close your eyes and picture yourself floating between galaxies. At first, the distance seems vast but steady. Then, slowly, the space around you begins to widen. The galaxies recede, not because they are moving, but because the space between you and them is swelling. You reach out, but they slip farther away. Faster and faster, the expansion grows. It is not violent. It is quiet, steady, inevitable. This is the work of dark energy, silent and patient, changing the destiny of the universe. There is a strange comfort in this thought. The universe is not static. It is alive, in motion, always becoming something new. Even the emptiness is not empty. It hums with energy, invisible but powerful. What we call nothing is not truly nothing. It is full of hidden force, full of unseen potential. Dark energy raises questions that reach beyond physics. If most of the universe is made of something we cannot see and do not understand, what does that say about our place in it? Perhaps reality is always larger than what we can measure. Perhaps the invisible is just as important as the visible, not only in the cosmos, but in life itself. The things we cannot see often shape us most deeply. In the distant future, the work of dark energy may reshape everything we know. If it continues as it is now, galaxies will drift apart until each cluster is alone, surrounded by darkness. If it grows stronger, it could one day tear even galaxies and stars apart, unweaving the universe thread by thread. If it changes, it could bring about outcomes we cannot even imagine. The future is written in the hands of an invisible force we barely understand. But here and now, dark energy is not something to fear. It is simply part of the quiet balance of existence. Dark matter holds the galaxies together. Dark energy stretches them apart, and between the two, the universe grows and evolves. We live in the middle of that balance, shaped by both forces, carried by both currents. So as you think tonight of the invisible universe, remember this: space itself is not empty. It is alive with a force that expands it, a hidden breath that carries galaxies outward. You are part of that same expansion, moving gently on the tide of dark energy. You may never see it, you may never feel it, but it is there, surrounding you, stretching the very space in which you rest. When we think about beginnings, we often imagine a single moment, a spark that sets everything into motion. For the universe, that moment was the birth of time and space itself. And though it happened nearly 14 billion years ago, we still carry the faint echo of it all around us. This echo is invisible to our eyes, but it surrounds us constantly, filling every corner of the sky. It is called the cosmic microwave background, the afterglow of creation. Picture the universe when it was young, not filled with stars and galaxies, but with a searing fog of energy and particles. Light could not travel freely because the universe was too hot and too dense. Photons scattered endlessly, bouncing from one particle to another, trapped in a brilliant haze. For nearly 400,000 years, the cosmos glowed like a furnace, but no light could escape clearly. It was a universe without stars, without structure, only a soup of energy and matter. Then slowly the universe expanded and cooled. The particles began to settle. Atoms formed, mostly hydrogen and helium. The fog lifted. For the first time, light could travel freely across space. The moment the universe became transparent, the light of its birth spilled outward, filling space forever. That light is what we now call the cosmic microwave background, a glow stretched thin by billions of years of expansion, but still here, still whispering. We cannot see it with our eyes because it has cooled into a form of light too faint and too long in wavelength. But with special instruments, astronomers can detect it. And when they map it, what they see is extraordinary. The entire sky glows with a faint radiation, the same in every direction, a perfect reminder that the universe had a common beginning. Imagine standing in a quiet room. Around you, everywhere, there is a soft hum, constant and unbroken. You may not notice it at first, but once you tune in, you realize it has always been there. That is what the cosmic microwave background is like. It is the hum of the universe itself, the faint warmth of its earliest moment, still echoing through time. What makes this invisible glow so remarkable is that it carries information. It is not perfectly smooth. It has tiny ripples, small fluctuations in temperature and density. These ripples were the seeds of structure. Where there was slightly more density, gravity would pull more strongly. And over time, those places grew into galaxies and clusters. In a very real sense, the cosmic microwave background contains the blueprint of the universe. When we look at it, we are looking at the universe as it was when it was only a few 100,000 years old. That may sound like a long time, but compared to nearly 14 billion years, it is like seeing the cosmos as an infant. The glow tells us what it looked like before stars ignited, before galaxies swirled, before planets formed. It is the closest thing we have to a photograph of creation. Close your eyes and try to picture it. A universe filled not with stars, but with a pale, uniform glow, like a warm fog of light. No galaxies, no suns, no earth, no life. Only a sea of hydrogen and helium, drifting in vast stillness, cooling slowly. From that stillness, tiny ripples would grow into everything we see today. The faint warmth of that glow is still here, washing through your body as you listen, passing through the air, through walls, through the earth itself. The light of creation never left. There is something deeply humbling about this. Every moment of your life has been surrounded by the ancient glow of the universe's birth, even if you cannot see it. Every star that has ever shone, every planet that has ever formed, every life that has ever emerged has unfolded against the backdrop of this invisible afterglow. It is like a cosmic memory, always present, always whispering of beginnings. The discovery of the cosmic microwave background was a turning point. Before it, the idea of the universe having a beginning was only a theory. After it, the evidence was undeniable. The glow confirmed that the universe truly had a moment of birth, that it expanded from a hot, dense state, that it has been growing ever since. The invisible hum became proof that the universe is not eternal and unchanging, but dynamic, alive with history. And yet, there is more to it than science. To think that the universe carries its own memory, imprinted in light, is almost poetic. It means that nothing is ever fully gone. Even the first moments are still here, stretched across space, woven into the background. The universe itself remembers its birth, and we are part of that memory. As you imagine this tonight, let it comfort you. You are surrounded not only by stars and galaxies, but by the faint warmth of the very beginning. You are cradled by the glow of creation, the same light that has been traveling for nearly 14 billion years. It passes through you quietly, unnoticed, yet it connects you to the origin of everything. The invisible universe is not silent. It hums with the afterglow of its first breath. And when you think about that, when you picture yourself wrapped in the gentle warmth of cosmic memory, You realize that you are not separate from the story of the universe. You are living within it, carried forward by light that has been shining since the beginning of time. There are particles moving through you right now, countless streams of them, silent and undetectable to your senses. They pass through your body, through the walls of your home, and even through the earth itself, as though none of it were there. These particles are called neutrinos, and they are among the most mysterious messengers of the invisible universe. Imagine for a moment that the universe is a vast ocean, and every star is a lighthouse casting out waves of particles. Most of those waves are blocked, absorbed, or scattered by matter. But neutrinos are different. They slip through almost everything, carrying with them stories from the heart of stars, from exploding supernovae, and even from the birth of the universe itself. To exist in the cosmos is to live immersed in a quiet rain of neutrinos, even if you never notice them. Neutrinos are sometimes called ghost particles because they interact so rarely with matter. Trillions of them are moving through you every second, yet in your entire lifetime, only a handful will ever actually strike an atom in your body. They are nearly massless, almost invisible to the forces that affect other particles, yet they are everywhere. Every nuclear reaction, from the core of the sun to the radioactive decay of elements on Earth, produces neutrinos. They are born in abundance, and they travel freely through space, crossing unimaginable distances. Think of the sun. Its warmth and light sustain life on Earth, but deep within its core, nuclear fusion is also producing a flood of neutrinos. Every second, billions upon billions stream outward, and many of them pass directly through our planet. When you stand in sunlight, you feel warmth on your skin, but you are also being bathed in neutrinos that carry messages from the sun's hidden heart. They reach you faster than the heat of the sunlight itself because they escape the sun almost instantly, while light takes thousands of years to climb its way out from the dense stellar interior. Supernovae, the great explosions that mark the death of massive stars, are also powerful sources of neutrinos. When a star collapses, the blast releases more energy in the form of neutrinos than in light. In fact, the flood of neutrinos is what drives the explosion itself, blasting outer layers into space, seeding the cosmos with heavy elements. Without neutrinos, supernovae would not unfold as they do, and the universe would be poorer for it. In their invisible silence, neutrinos shape the grand cycles of stars and galaxies. Even the Earth is a source of neutrinos. Deep underground, radioactive elements decay, producing streams of them that escape outward. As you sit quietly, the very ground beneath you is humming with invisible particles, born in the hidden heat of the planet's interior. These geoneutrinos tell us about the deep Earth, a realm we cannot reach directly. In this way, neutrinos are like windows into places we could never otherwise see, carrying whispers of the hidden world into the open. Detecting neutrinos is one of the most difficult challenges in science. Because they rarely interact, they pass through detectors unnoticed. To catch even a few, scientists build vast chambers deep beneath the Earth, shielded from light and noise, filled with pure water or special liquids. Every so often, a neutrino collides with an atom, releasing a faint flash of light. By watching for these flashes, scientists can study particles that would otherwise remain ghosts forever. It is an extraordinary effort, like waiting to hear a single drop of rain in a roaring storm, but it is enough to let us glimpse the invisible. What we have learned from these faint flashes is astonishing. Neutrinos are not completely massless as once believed. They have tiny amounts of mass, so small they were overlooked for decades. This mass, however, may hold clues to the very structure of the universe. If we can understand why neutrinos are the way they are, we may learn why matter exists at all. Some theories suggest that neutrinos helped tip the balance in the early universe, favoring matter over antimatter, allowing galaxies, stars, and life to form. In that way, these ghostly particles may have shaped everything we know. Close your eyes and imagine neutrinos as rivers of invisible particles flowing everywhere at once. From every star, from every explosion, from the very earth beneath your feet, they stream through space without end. They slip through your body in silence, unnoticed but constant, like a hidden tide. You are immersed in them every moment of your life, just as you are immersed in air and light. They are a reminder that the invisible universe is not far away. It is here, always present, moving through you. There is a gentle poetry in the idea that we are bathed in ghost particles. It reminds us that we are not separate from the cosmos, but part of its flows and cycles. Just as sunlight nourishes us and air sustains us, neutrinos pass through us as if we are transparent, weaving us into the quiet web of invisible energy. To exist is to be connected to these streams, to carry within us the touch of stars, explosions, and the earth itself. The invisible universe is full of mysteries, but neutrinos show us that mystery can also be intimate. It is not only in distant galaxies or hidden dimensions. It is in every breath you take, every moment you sit in the quiet. The unseen flows through you, reminding you that the cosmos is both vast and close, both unreachable and deeply personal. As you let this thought settle tonight, imagine yourself drifting in a sea of neutrinos, weightless and calm. They pass through you gently, carrying no harm, only quiet reminders of the stars. They come from the sun, from ancient explosions, from the ground beneath your feet. They tie you to the whole of the universe, invisible but real. The ghost particles are with you, always. There is a kind of invisibility that is even stranger than dark matter, dark energy, or ghostly neutrinos. It is the invisibility of a place where light itself disappears. These places are black holes, regions of space where gravity is so strong that nothing, not even light, can escape. They are perhaps the most dramatic examples of the invisible universe because they do not just hide from our eyes, they erase the very possibility of seeing. A black hole begins with a star. Imagine a star many times larger than our sun, burning fiercely, its core blazing with nuclear fire. For millions of years it shines, but eventually the fuel runs out. Without the heat and pressure of fusion to hold it up, the star collapses inward. For some stars, this collapse ends in a brilliant supernova, leaving behind a dense neutron star. But for the most massive stars, the collapse continues without end, crushing matter into a point of infinite density. That point, hidden behind an invisible boundary, is a black hole. The boundary is called the event horizon. It is not a physical surface, but a threshold. Once something crosses it, whether a particle, a star, or even a ray of light, it can never return. From the outside, we cannot see what happens within. The black hole becomes an invisible well, its presence known only by the way it warps space and bends the paths of nearby objects. Imagine space as a great fabric. Normally it stretches smoothly, curving gently around stars and planets. But where a black hole lies, the fabric plunges downward, so steep that not even light can climb out. We cannot see the black hole itself, but we can see the way it bends space, twisting light from stars behind it, curving orbits, and drawing matter inward. It is like watching a whirlpool in the ocean, where you cannot see the water below but can feel the pull of the current. Despite their invisibility, black holes are far from empty. Around them, matter often collects into glowing disks. Gas and dust spiral inward, heated to millions of degrees as they fall. These disks shine brilliantly in X-rays and other forms of light we cannot see with our eyes. Sometimes, jets of particles are launched outward at nearly the speed of light, shooting across galaxies like cosmic lighthouses. In this way, black holes announce their presence not by what escapes from within, but by the chaos they cause just outside their boundaries. There are many sizes of black holes. Some are formed from collapsing stars and are only a few times more massive than the Sun. Others are far larger, millions or even billions of times more massive, lurking at the centers of galaxies. Our own Milky Way has one of these giants, a supermassive black hole with the mass of millions of suns. Though it is invisible, astronomers have watched stars whip around it at incredible speeds, tracing paths that reveal the gravity of the hidden monster at the core. The existence of supermassive black holes raises profound questions. How do such giants form? Did they grow slowly over billions of years, or were they born large in the early universe? Their invisible presence shapes galaxies, influencing the growth of stars and the flow of matter. Without them, galaxies might not evolve as they do. The invisible is not only present, it is essential. Perhaps the strangest thing about black holes is the way they challenge our understanding of space and time. Near the event horizon, time itself slows. To an outside observer, a falling object seems to freeze at the edge, never quite crossing, though in its own experience it plunges inward without pause. Space and time stretch and twist in ways that defy ordinary imagination. The black hole is not just an invisible object, it is an invisible distortion of reality itself. Close your eyes and picture yourself drifting near one. The stars bend and warp around it, their light curving into arcs. Ahead lies a region of darkness, perfectly black, outlined only by the glow of matter spiraling inward. You move closer and time begins to stretch. Minutes outside become hours for you, then days. To those watching from afar, you seem frozen, though to you, everything continues. It is a place where the rules we know no longer hold, where the invisible swallows not only matter and light, but the very flow of time. There is a haunting beauty in this idea. Black holes are terrifying in their power, yet they are also deeply fascinating. They remind us that the universe is not limited to what we can see or imagine. It contains realms where our usual concepts fail, where invisibility is not just absence but transformation. Even though we cannot look inside, black holes may hold clues to the deepest mysteries. What happens to information that falls in? Is it lost forever? Or does it leave some faint trace behind? Could black holes be gateways to other places, other times, or other universes? These questions remain unanswered, lingering at the edge of science and imagination. The invisible universe hides its secrets well, but it also invites us to dream. As you let these thoughts drift through you tonight, remember that black holes are not faraway fantasies. They are real, scattered across galaxies, including our own. They shape the stars, bend light, and sculpt the cosmos. They are invisible, yet their influence is everywhere. To wonder about them is to accept that the universe is stranger than we know, and that mystery is not something to fear, but something to embrace. There are times when the invisible universe does not simply sit silently around us, but moves, stretches, and ripples in ways that are almost impossible to imagine. Space and time themselves are not fixed or unchanging. They can bend, flex, and vibrate like the surface of a great cosmic pond. These movements are called gravitational waves, and though they are invisible, they carry the stories of the most powerful events in the cosmos. Imagine throwing a stone into water. The impact sends ripples outward in expanding circles, carrying energy across the surface. In much the same way, when massive objects in the universe collide or move violently, they send out ripples, not through water, but through space and time itself. These ripples are gravitational waves. They travel across the universe at the speed of light, passing through stars, planets, and even your own body without resistance. You cannot feel them, yet they are there, part of the hidden music of reality. Gravitational waves were predicted long before they were detected. They arise naturally from the theory of general relativity, which describes gravity as the bending of space and time by mass. When that mass moves suddenly, the curvature of space shakes, sending waves outward. For decades, these waves remained only an idea, too faint to measure with the tools available. But astronomers never stopped listening, convinced that if they could detect them, they would open a new way of seeing the invisible universe. The first direct detection came from the collision of two black holes more than 1 billion light-years away. In that distant event, two massive objects spiraled closer and closer until they merged, releasing more energy in a fraction of a second than all the stars in the observable universe combined. Most of that energy escaped not in light, but in gravitational waves, ripples that spread outward, crossing the void until they reached Earth. When they arrived, they moved through our planet, stretching and squeezing space by a fraction of the width of a single atom. Instruments sensitive enough to measure this tiny change confirmed what had once been only a dream. The invisible had spoken, and we had heard it. Gravitational waves are extraordinary, because they let us observe things that light cannot reveal. When black holes collide, no light escapes. To ordinary telescopes, such an event would be invisible. But gravitational waves carried the signature of the collision, allowing us to know it happened, to measure its mass and its motion, and to hear the rhythm of its final moments. In this sense, gravitational waves are like ears for the cosmos, letting us listen to events that our eyes could never see. Close your eyes and imagine the sound of the universe. Not sound in the way we hear with air and ears, but a deeper resonance, a vibration of the fabric of existence. A pair of black holes spiraling together sends out a steady rhythm, faster and faster, higher and higher, until they merge in a final burst. The waves spread outward forever, carrying the memory of that moment. If you could translate it into sound, it would be like a faint rising note, a cosmic chirp echoing across eternity. But black holes are not the only sources. Neutron stars, the collapsed remnants of massive stars, also collide and send ripples across space. Unlike black holes, neutron stars contain matter, and when they smash together, they create both gravitational waves and light. By studying both signals, astronomers can piece together a fuller story of these extraordinary events. From such collisions come the heavy elements that form planets and even life. The gold in a ring, the iodine in your body, the uranium buried deep in Earth, all may have been forged in the fire of colliding neutron stars, carried to us by the invisible waves of the cosmos. The idea that you are connected to these events is humbling. When you look at a piece of jewelry, or consider the trace elements within your body, you are touching the aftermath of collisions so powerful they shook the fabric of space. Those ripples are still moving outward, still traveling through the universe, still carrying energy and information across billions of light years. The invisible is not far away. It is part of you. Gravitational waves remind us that space is not empty. It is dynamic, alive, capable of movement and change. When you walk across a room, the space beneath your feet seems solid, unmoving, but on the largest scales, space can flex like an ocean. When stars collapse or black holes merge, the whole universe vibrates in response. The invisible becomes motion, and motion becomes story. Detecting gravitational waves is not easy. The changes they cause are so small that it takes instruments stretching for kilometers, lasers bouncing between mirrors, and computers measuring shifts smaller than an atom. These detectors must be isolated from noise, shielded from vibrations, and watched with extreme care. Yet even with all this effort, they work. The universe speaks in whispers, and we have learned to hear them. The future of gravitational wave astronomy promises even more. With improved instruments, we may hear the ripples from the earliest moments of the universe itself, the vibrations left over from the first expansion after the beginning of time. We may listen to the quiet hum of countless black holes colliding across cosmic history, building a symphony of invisible notes. We may even hear signals we cannot yet imagine, surprises hidden in the fabric of reality. There is something deeply calming in this idea. The universe is filled with invisible music, rippling endlessly through space. You cannot feel it on your skin, but it is there, passing through you even now. Every moment of your life, gravitational waves are moving silently through your body, carrying stories from distant galaxies, stories of collapse, collision, and creation. You are bathed in the vibrations of reality itself. As you let this thought rest in your mind, imagine yourself floating on a vast ocean. You cannot see the waves, but you can sense their presence, endless, gentle, and profound. They pass through you like the slow breath of the universe, a reminder that you are part of a story far larger than yourself. The invisible is always near, always moving, always carrying the echoes of the cosmos. When you look up at the night sky, it may seem as if the stars are scattered randomly, spread across the heavens without order, but on the largest scales, the universe has structure. Galaxies are not isolated islands drifting aimlessly. They are bound into groups, stretched into clusters, and linked by vast unseen threads that weave across billions of light years. This hidden pattern is called the cosmic web, and it is one of the most extraordinary aspects of the invisible universe. Imagine standing far above the cosmos, looking down as if it were a vast map. At first, you might see points of light, each one a galaxy. As you pull farther back, the pattern becomes clear. Galaxies gather into filaments, long chains stretching across space, separated by enormous voids where almost nothing exists. The result is a structure that looks like a web, a network of luminous strands with dark gaps in between. This web is the skeleton of the universe, and it is built mostly from invisible matter. The cosmic web is shaped by dark matter, that unseen substance that outweighs everything we can see. In the early universe, dark matter began to clump together under the pull of gravity. These clumps grew into filaments, forming the framework on which gas and stars would later collect. Without dark matter, the web would not exist. The galaxies we see today are like beads strung along invisible threads, shining only where the scaffolding of dark matter allowed them to gather. The scale of this web is beyond comprehension. A single filament can stretch across hundreds of millions of light years, connecting clusters of galaxies like bridges in space. The voids between filaments are just as staggering, immense regions almost empty, where very few galaxies can be found. These dark spaces make the bright filaments stand out even more, a reminder that the universe is both filled and hollow, both crowded and lonely. Close your eyes and picture yourself floating within this structure. Around you are galaxies, glowing softly like lanterns. They stretch into strands, lines that run outward in every direction, forming an endless network. Between them lie vast, dark spaces, quiet and empty. You drift along a filament, carried by the invisible presence of dark matter, feeling the pull of gravity that binds the web together. You are part of it, a tiny point within an immeasurable network. The cosmic web is not static. It grows and changes over time. As the universe expands, dark matter continues to draw matter into its filaments. Galaxies fall along the threads, clustering at the intersections where filaments meet. These intersections become nodes, giant clusters of galaxies containing hundreds or thousands of members. From each node, filaments stretch outward, linking cluster to cluster, a vast and interconnected system that spans the observable universe. In this way, the cosmic web resembles the networks we know on Earth. It looks like the filaments of neurons in a brain, the tangled lines of roots beneath a forest, or the patterns of veins in a leaf. The same shapes repeat across scales, from the smallest structures to the largest. It is as though the universe follows a hidden rhythm, building patterns that echo one another from the microscopic to the cosmic. The invisible universe reveals itself here in both presence and absence. The filaments are full of dark matter, unseen but powerful, while the voids are almost empty, silent spaces that stretch for unimaginable distances. Both are essential. Without the voids, the filaments would not stand out. Without the filaments, the voids would have no meaning. Together they form a balance, a cosmic yin and yang woven into the very fabric of reality. To imagine the cosmic web is to recognize how small we are. Our Milky Way is just one galaxy among billions, strung along one filament among countless others. From our perspective, the galaxy feels immense, yet it is only a single bead in the great structure. And yet, there is also comfort in this. We are not adrift in randomness. We are part of a larger design, held in place by invisible threads that stretch beyond imagination. The existence of the cosmic web also raises questions. Why does matter arrange itself this way? Why filaments and voids and not some other shape? Is there a deeper principle guiding the structure, or is it simply the natural result of gravity and expansion? These questions remind us that the universe is not only vast, but also profoundly mysterious, offering patterns that invite both awe and inquiry. As you rest tonight, picture the web stretched across the darkness. Picture the galaxies glowing like tiny gems along strands of invisible matter. Picture the voids, immense and silent, surrounding the filaments like deep oceans around islands. You are part of this web. The atoms in your body, the planet you rest on, the stars you see above, all are woven into the same network. The invisible threads carry you, connect you, and hold the universe together. The cosmic web is a reminder that the universe is both visible and hidden, both simple and intricate. It shows us that structure can emerge from silence, that beauty can arise from forces we cannot see. And it reminds us that even in the vastness, we are never alone. We are part of a web that stretches across all of space, binding galaxies, stars, and life into one great cosmic tapestry. When we think of the universe, our minds often turn to the crowded places. We picture glowing galaxies, clusters of stars, swirling nebulae, and the busy filaments of the cosmic web. But just as important as these regions of light are the regions of silence. Between the strands of the web lie vast spaces that are almost completely empty. These are the cosmic voids, immense expanses where galaxies are rare and where darkness reigns. They are not just gaps between the stars. They are some of the largest structures in the cosmos, and they belong to the invisible universe. Imagine yourself drifting outward from a galaxy cluster, past the shining filaments of galaxies that stretch like threads of light. As you move farther, the glow begins to thin. Galaxies become fewer, scattered sparsely like embers fading in a fire. Then, at last, you find yourself surrounded by emptiness. In every direction there is darkness, stretching for hundreds of millions of light years. This is a cosmic void, a region so empty that it seems almost outside of creation, and yet it is part of the universe itself. Voids are not small gaps. They are enormous, often spanning hundreds of millions of light years across. To give perspective, our entire Milky Way galaxy is about 100,000 light years wide. A void can be thousands of times larger, containing almost nothing in its vast expanse. And yet, even within these empty regions, there are faint traces. A few galaxies may drift in the silence, lonely islands in a sea of nothing. Clouds of hydrogen may float, so thin they are almost undetectable. But compared to the filaments and clusters, these voids are emptiness on a scale beyond comprehension. The existence of voids might seem unsettling. Why would the universe have such enormous empty spaces? But in truth, voids are just as natural as filaments. They are the spaces left behind when matter gathers elsewhere. Imagine dough rising in an oven, with bubbles forming as pockets of air push the dough outward. The filaments of galaxies are like the dough that has stretched and clumped, while the voids are the empty bubbles in between. They are the negative of the cosmic web, the dark spaces that give shape to the light. What makes voids part of the invisible universe is not just their emptiness, but what they reveal. By studying the few galaxies that do exist inside them, astronomers can learn how matter behaves when it is free from the strong pull of dense clusters. The isolation of voids makes them quiet laboratories for the universe, places where hidden forces such as dark energy can be felt more clearly. In a way, voids are not empty. They are full of subtle clues, whispers of the unseen. Close your eyes and imagine yourself floating inside one of these immense spaces. There is no nearby star to warm you, no cluster of galaxies to illuminate the sky. The darkness is vast and deep, stretching so far that it almost feels infinite. Yet in that silence, you sense the presence of the universe still. The faint glow of galaxies far away dots the horizon, tiny sparks in the endless night. You are not outside creation. You are in its quietest chamber, wrapped in the stillness of the cosmos. Voids remind us that emptiness has its own kind of beauty. Just as a painting needs empty space to balance its colors, the universe needs voids to balance its structures. Without the dark gaps, the filaments would lose their meaning. Without silence, sound would lose its shape. The voids are not mistakes or absences. They are part of the design as essential as the galaxies themselves. They also challenge us to rethink what nothing means. True nothingness may not exist. Even in the deepest voids, space itself stretches. Dark energy continues to expand, invisible but real. Neutrinos drift endlessly, passing without care through the emptiness. The faint glow of the cosmic microwave background still bathes the region, a reminder that even in apparent silence, the echo of creation endures. The void is never truly empty. It is simply quieter, subtler, less obvious to our eyes. Voids may even hold answers to some of the greatest mysteries. Because they are so empty, they may reveal the fingerprints of dark energy more clearly than crowded regions. In clusters and filaments, gravity and matter complicate the picture. But in voids, where little else is present, the push of expansion stands out more starkly. To study a void is to listen to the universe in its quietest voice, stripped of distractions. What we learn there may help us understand the invisible forces that guide everything. On a more human level, the thought of cosmic voids can feel strange. To imagine such vast emptiness, larger than entire clusters of galaxies, can stir a sense of unease, but it can also bring peace. The void is not hostile. It is not violent. It simply is, stretching silently across space, a calm counterbalance to the brilliance of galaxies. To rest your thoughts in the idea of a void is to rest in stillness itself, to allow silence to fill you, as the universe allows silence to fill its largest spaces. The invisible universe is not only made of hidden forces and unseen matter, it is also made of emptiness, of gaps and hollows that give shape to the whole. The cosmic voids are reminders that the universe is vast beyond imagination, but also balanced, patterned, and complete. Even the emptiest regions are part of the story, woven into the grand design of the cosmos. As you let this image rest in your mind tonight, picture yourself in the heart of a void. Around you, silence stretches without end. Far away, galaxies glimmer faintly, tiny sparks in the dark. You are surrounded by emptiness, yet not abandoned. You are still part of the universe, still held by its invisible currents. The void is not absence. It is presence in another form, a quiet presence that offers calm and perspective. There are events in the universe so powerful that they cannot be hidden, yet their most important signals are invisible. Among these events are the collisions of black holes. These are not gentle meetings, but violent dances where gravity reigns supreme, where matter and space itself are reshaped. When black holes merge, they release immense amounts of energy, yet not in the form of light. Instead, their signature is carried in invisible ripples of space-time and in the unseen shaping of galaxies around them. Imagine two black holes circling each other. For millions of years they drift closer, locked in a gravitational embrace. With each orbit they lose energy, sending out faint gravitational waves that ripple across the universe. Slowly, patiently, the dance tightens. The circles grow smaller. The motion grows faster. Until finally, they crash together in a moment of unimaginable force. From the outside, we see no flash of light. The black holes do not shine. But the fabric of space-time itself shakes, sending ripples that travel across billions of light years, reaching us long after the event. These collisions are among the most extreme tests of nature's laws. They happen far beyond our reach, in regions of space so distant and hidden that no telescope could ever capture the moment directly. Yet the invisible signature of their merging arrives here, passing through our planet, through our bodies, as subtle shifts in space. Instruments detect them as tiny changes in distance, smaller than an atom, yet carrying the story of massive objects colliding. The invisible universe speaks through these waves, and we are learning to listen. But the story of black hole collisions is not only told through ripples. These events shape galaxies in quiet ways that we cannot always see. Many galaxies host supermassive black holes at their centers, millions or billions of times heavier than the Sun. Sometimes galaxies merge with one another, and when they do, their central black holes are pulled together. For millions of years they spiral inward, stirring the gas and stars around them, feeding on matter, and launching jets of particles that stretch for thousands of light years. These invisible forces sculpt the galaxies, influencing where stars form, where gas flows, and how the structure evolves. It is strange to think that invisible objects colliding in silence can shape the luminous beauty we see in the night sky. But this is the way of the universe. The visible is only the surface. The invisible is the foundation. Without these hidden dances, galaxies might grow differently, their shapes and stars arranged in unfamiliar ways. The universe we see is built upon collisions we cannot see. Close your eyes and picture this dance. Two black holes orbit each other, faster and faster, spiraling like whirlpools in a dark sea. They do not shine, but their motion stirs the space around them. As they near the end, the pace quickens. The orbits blur into one. Then suddenly, they merge, disappearing into a single larger black hole. A wave spreads outward, invisible but real, carrying the memory of that moment forever into space. If you could translate it into sound, it would be a rising note, a cosmic sigh as the two become one. In these moments, time itself seems to tremble. The collision alters the flow of space around it, creating distortions that remain long after. The merged black hole rings like a struck bell, sending out waves as it settles into a new shape. We cannot see this ringing, but we can detect its ripples in space-time. It is as though the universe itself vibrates, singing a song too deep for our ears, but clear in its message. These invisible events remind us that the universe is not quiet, even when it seems so. While we look at the stars and see only stillness, great collisions are happening far away, hidden behind the curtain of darkness. Their signals are faint but constant, moving silently through the cosmos, brushing past us without harm. Every second, countless black holes may be merging, sending out ripples that pass through your body, unnoticed but real. The study of black hole collisions also opens questions that stretch our imagination. What happens at the moment of merger, when two singularities combine? Does information vanish inside, or is it preserved in ways we do not yet understand? Could these events reveal new physics, hints of laws beyond what we know? The invisible universe is not just a place of mystery. It is a place of possibility where answers to the deepest questions may be hidden. There is a calm irony in the thought that the most powerful events in the universe can pass through you without notice. The merger of black holes billions of light years away can send waves through your body, stretching and compressing space itself, yet so subtly that you would never feel it. The invisible is both mighty and gentle, both unstoppable and delicate. As you rest tonight, imagine the quiet rhythm of these collisions. Imagine the universe filled with ripples, each one the echo of a cosmic dance long past. You are part of that rhythm, carried by the same space-time that shakes when black holes merge. The invisible currents flow through you, connecting you to galaxies and stars you will never see. You are living in a universe alive with motion, even if your eyes cannot witness it. When a star dies, it can leave behind one of the most dramatic displays in the cosmos, a supernova. To our eyes, a supernova is a burst of light, a sudden flare that outshines entire galaxies for a brief time before fading. But the true story of a star's death is told not by the light we see, but by the invisible flood of particles that escapes in the first instant. These particles are neutrinos, and they are the first messengers of a supernova, carrying the hidden truth of stellar death across the universe. Imagine a massive star nearing the end of its life. For millions of years, it has burned brightly, fusing hydrogen into helium, and then forging heavier and heavier elements in its core. But eventually, the core becomes iron, and iron cannot burn to release more energy. The balance tips, and the star can no longer hold itself up against gravity. In a sudden, catastrophic moment, the core collapses inward. This collapse happens so quickly that the star's heart implodes in less than a second. The core becomes a dense ball of neutrons, and the outer layers slam into it, rebounding outward in a tremendous explosion. To us, the light of that explosion takes minutes to hours to emerge, climbing through the star's layers before racing into space. But the neutrinos, born in the very heart of the collapse, escape almost instantly. They stream outward in a vast flood, carrying most of the energy of the supernova. By the time the star's light finally reaches us, the invisible neutrinos have already passed. Neutrino bursts from supernovae are unimaginably intense. In a single event, more neutrinos are released than in all the stars in the universe combined over that same moment. They carry away the story of the collapse, the violence of the explosion, and the transformation of the star into a neutron star or black hole. They are the silent heralds of endings, arriving first, unseen, but unmistakable to those who know how to listen. The discovery of this truth came not from theory alone, but from a rare event. In the year 1987, a supernova exploded in a nearby galaxy called the Large Magellanic Cloud. It was bright enough to be seen with the naked eye, the closest such explosion observed in centuries. But even before the visible light reached telescopes, detectors on Earth recorded a handful of neutrinos, the first ever caught from a star's death. In that moment, we realized that neutrinos were not just invisible background particles, but vital messengers carrying news from the deepest places in the cosmos. Imagine for a moment that you are floating in space near such a star. At first, the star shines as usual, steady and constant. Then, in an instant, the core collapses. If you had instruments sensitive enough, you would feel a sudden flood of particles sweeping past you, silent and unstoppable. Only later would the light burst forth, blinding and brilliant. The neutrinos are always the first signal, the whisper before the shout, the hidden truth before the visible display. Why are neutrino bursts so important? Because they let us see what no telescope can. Light is slowed and scattered by the outer layers of the star, hiding the first moments of collapse. Neutrinos, however, pass straight through, escaping unhindered. By capturing them, scientists can peer into the very heart of a dying star, learning how the explosion unfolds, how elements are forged, and how the universe is enriched. Every atom of oxygen you breathe, every atom of calcium in your bones, every trace of iron in your blood was forged in ancient stars and scattered into space by supernovae. Neutrinos were there at the moment of release, carrying away the energy that allowed those elements to be cast into the cosmos. Without the invisible flood of neutrinos, the explosion itself would not succeed. They are not only messengers, they are participants in the story of creation. The scale of this is staggering. Imagine trillions upon trillions of particles flying outward in all directions, passing through galaxies, through planets, through countless forms of matter without stopping. Most of them will never interact with anything, traveling forever through the universe. A few may strike atoms in detectors deep underground, offering us faint flashes of light that tell us they were here. The rest move silently, unnoticed, yet still shaping the fate of the cosmos. There is a quiet lesson in this. The most powerful events in the universe are not always the ones we can see. Often, they are carried in the invisible, in the floods of particles that pass without fanfare. The universe speaks in whispers as well as in shouts, and the neutrinos of a supernova are among its softest yet most profound voices. Close your eyes and picture the death of a star. Not the light, though it is magnificent, but the invisible flood of particles rushing outward, touching everything in their path. Picture them passing through you, through Earth, through all that exists, connecting the end of a star's life to your own. The oxygen you breathe, the iron in your blood, the calcium in your bones, all trace their origins to such events. You are linked to the invisible messengers, bound to the story they carry. As you rest tonight, consider that the universe has always been speaking, even if most of its voice is invisible. Neutrinos pass through you constantly, some born in the sun, some in the earth, and some from supernovae long past. Each one is a reminder that the cosmos is alive with motion, transformation, and connection. The invisible universe is not distant. It is woven into every breath, every thought, every quiet moment. The universe is filled with forces that we cannot see, yet they guide and shape everything around us. Among the most mysterious of these are magnetic fields, invisible lines of force that stretch across galaxies, stars, planets, and even the vast spaces in between. Though they cannot be touched or seen directly, magnetic fields are everywhere, threading through the cosmos like hidden strings, guiding the dance of matter and energy. We are familiar with magnetism in our everyday lives. A small magnet can pin a note to a refrigerator. A compass can point north by aligning with Earth's magnetic field, and electric currents can create powerful magnetic forces. But in the universe, magnetism operates on scales far greater than anything we experience at home. Entire galaxies are wrapped in invisible magnetic fields, and stars are shaped and influenced by their magnetic energy. These fields are subtle and quiet, but their effects are profound. Imagine a galaxy, a vast spiral of stars, dust, and gas. To your eyes, it looks luminous and serene, a graceful whirlpool of light. But surrounding it and weaving through it are magnetic fields, stretching from star to star, guiding the flow of charged particles and influencing the birth of new suns. We cannot see these fields, but their fingerprints are everywhere, in the arcs of cosmic rays, in the shapes of glowing gas clouds, and in the quiet order that emerges from chaos. Our own Earth is protected by a magnetic field. Deep within the planet, molten iron churns and moves, creating currents that generate magnetism. This invisible shield stretches far into space, deflecting charged particles from the sun and shielding life from harmful radiation. Without it, the atmosphere might have been stripped away long ago, and the planet could have become barren like Mars. Though we never see Earth's magnetic field, it surrounds us constantly, holding back invisible storms from space. Stars also have magnetic personalities. On the sun, magnetic fields twist and tangle, creating sunspots, solar flares, and eruptions of plasma that arc high into space. These outbursts send streams of charged particles racing outward, carried by the sun's magnetic breath. When they reach Earth, they create auroras, curtains of light dancing in the sky, a visible display of an invisible force. Every flicker of green or red light in the polar skies is a reminder that magnetic fields, though unseen, shape the beauty of the world around us. On larger scales, magnetic fields become even more mysterious. Between galaxies, in the vast reaches of intergalactic space, faint magnetic fields stretch across millions of light years. How they came to exist is still not fully understood. Were they born in the earliest moments of the universe, seeded by tiny fluctuations during the first expansion of space? Or did they grow later, amplified by the movement of matter and energy? Whatever their origin, they are now part of the cosmic landscape, invisible threads binding the great structures of the universe together. Close your eyes and picture the invisible lines of force. They do not glow or shine, but they are there, guiding the paths of particles, bending their motion, shaping their flow. Picture a galaxy as a great river of stars, and then picture invisible currents beneath the surface, unseen but powerful, carrying energy across space. The stars shine, but the magnetic fields guide the hidden dance, silent and steady. One of the most striking effects of magnetic fields is seen in jets from black holes and neutron stars. Around these dense objects, matter spirals inward, heated to extreme temperatures. Magnetic fields twist the plasma, channeling it into narrow beams that shoot outward at nearly the speed of light. These jets can stretch for thousands of light years, visible across galaxies. Yet they are powered by invisible magnetic fields, unseen but essential. Without them, the energy of these systems could not be released in such spectacular ways. Magnetic fields also shape the birth of stars. In dense clouds of gas and dust, gravity pulls matter inward, but magnetic fields thread through the clouds, resisting collapse and guiding the flow of material. The balance between gravity and magnetism determines how stars form, how large they become, and even whether planets can gather around them. Every star you see in the night sky was influenced, quietly and invisibly, by magnetic fields long before it ever began to shine. Even our bodies carry a trace of the magnetic world. Small amounts of iron in our blood respond faintly to strong magnetic fields, and some animals have evolved senses that let them navigate using Earth's field. Birds can follow invisible lines across continents, guided by a force we cannot perceive. In this way, magnetism weaves not only through the stars, but also through life itself, linking the cosmos to the living world in quiet ways. The invisible universe of magnetism is full of mysteries still unsolved. Why are magnetic fields so widespread? How did they first arise? Do they play a deeper role in the structure of the cosmos than we realize? These questions linger, waiting for answers hidden in the silence of the universe. What we do know is that without magnetism, the universe would look very different. Galaxies would not form as they do, stars would not shine as they do, and life on Earth might never have come to be. As you think of this tonight, imagine yourself surrounded by invisible threads. They are not chains but currents, flowing gently through the cosmos, weaving galaxies, guiding stars, shielding planets. They pass through you too, subtle and unseen, but real. You are part of the magnetic universe, carried along by forces you cannot see but that shape your world in every moment. The invisible universe speaks in many ways, through dark matter, through neutrinos, through gravitational waves. But it also speaks in silence, in the quiet strength of magnetic fields, invisible but enduring, guiding the story of creation. You are held within those fields, part of the same dance that stretches across galaxies and stars. The lines may be unseen, but they connect you to the cosmos, threading your existence into the vast and hidden fabric of reality. When we look at the night sky, we see only a narrow slice of the universe's light. Our eyes are tuned to a small band of wavelengths we call visible light, stretching from red to violet. But the cosmos shines across a far broader spectrum, a vast symphony of invisible radiation that our senses cannot detect. This hidden light, from long radio waves to fierce gamma rays, carries the deeper story of the universe, a story written in colors we cannot see. Imagine the sky as a great canvas, painted only in one shade, and imagine that there are countless other shades, invisible to you but still present. This is how the universe appears to us. Our eyes show us the stars, the planets, the galaxies, but they hide the immense richness of radiation beyond. When astronomers build instruments that can see in other wavelengths, the universe transforms. Quiet galaxies glow with radio waves, cold clouds shine in microwaves, and violent explosions blaze in X-rays and gamma rays. The invisible becomes visible, and the cosmos reveals its true depth. Radio waves are the longest form of light, with wavelengths stretching across meters, kilometers, even longer. They carry little energy, but they travel easily, slipping through dust and gas that block visible light. With radio telescopes, astronomers peer into the hidden hearts of galaxies, seeing jets of matter launched by black holes, structures invisible to ordinary eyes. They map the cosmic web itself, tracing hydrogen across billions of light years. To the naked eye, the universe looks quiet. In radio light, it hums with energy, alive with structure and flow. Microwaves, slightly shorter than radio waves, also fill the universe. The most famous source of microwaves is the cosmic microwave background, the afterglow of the universe's birth, bathing every corner of space with faint radiation. Though invisible to our eyes, it surrounds us constantly, carrying the memory of creation. Every moment of your life has been immersed in this ancient glow, a reminder that the invisible is never far away. Infrared light lies just beyond the red we can see. It is the glow of warmth, the radiation emitted by objects not hot enough to shine visibly. A star-forming cloud, cold and dark in visible light, shines brilliantly in infrared, revealing newborn suns hidden inside. Even your own body glows in infrared, radiating warmth into the air. To infrared eyes, the world would be filled with soft heat signatures, invisible to us but constant. In the universe, infrared reveals hidden galaxies, enshrouded in dust, unseen in visible light, yet blazing with invisible fire. Above visible light lies ultraviolet, a form of radiation more energetic than our eyes can perceive. Young stars blaze in ultraviolet, their fierce energy shaping the gas clouds around them, sculpting regions of space into glowing nebulae. Though our atmosphere blocks much of it from reaching Earth's surface, ultraviolet is constantly pouring from the stars, filling space with invisible brilliance. It is a reminder that the universe shines brighter than we can ever know. Beyond ultraviolet lies the realm of X-rays. Here the universe becomes violent. X-rays are born in the hottest, most extreme environments. The disks of matter spiraling into black holes, the surfaces of neutron stars, the shock waves of supernova remnants. We cannot see them with our eyes, but instruments reveal skies filled with invisible storms, energy blazing across space. Every second, X-rays stream through the universe, carrying the stories of collapse, collision, and transformation. At the highest energies lie gamma rays, the most powerful form of light. Gamma rays are born in the death throes of stars, in the collisions of neutron stars, in the mysterious bursts that erupt without warning. They carry immense energy, yet they vanish quickly, absorbed by matter or transformed by interactions. To detect them, astronomers must build sensitive instruments high above Earth, watching the sky for brief but extraordinary flashes. These flashes are the universe's most dramatic fireworks, invisible to our eyes but undeniable in their power. When you think about this invisible spectrum, it changes how you see the universe. The stars you notice with your eyes are only a fraction of the story. The true sky is filled with radiation across every wavelength, each band carrying a different piece of the puzzle. Some reveal calm structures, others reveal violent events, but together they weave a complete picture of the cosmos. The invisible light is not secondary. It is essential, without which we would know only the surface of reality. Close your eyes and imagine the night sky transformed. Instead of scattered stars on blackness, imagine threads of radio waves connecting galaxies, clouds glowing in infrared, jets blazing in X-rays, bursts erupting in gamma rays. The sky would no longer seem quiet. It would be alive, filled with motion, energy, and change. The universe we think of as serene would be revealed as dynamic, restless, and endlessly rich. Even though we cannot see these forms of light directly, they touch us constantly. Radio waves pass through you every moment from distant galaxies and from sources on Earth. Infrared warmth surrounds you, streaming from your own body and everything nearby. X-rays from the sun are absorbed by the atmosphere, but their presence is felt in the auroras that dance in the polar skies. Gamma rays from distant events occasionally brush the planet, faint reminders of cataclysms far away. You are immersed in invisible light, a constant flood of radiation across the spectrum, part of the fabric of your existence. The invisible universe speaks through these wavelengths, each one a voice telling part of the story. To listen only to visible light is like hearing only one note of a vast symphony. To listen across the spectrum is to hear the full music, the harmony and the chaos, the calm and the violent, all woven together. The universe is not silent. It sings in radiation across all scales, and though our eyes cannot see it, we are always part of its song. As you rest tonight, imagine yourself lying beneath the sky of invisible light. Above you, the air is filled with waves of energy, long and short, faint and fierce. They pass through you, through Earth, through everything, carrying messages from stars, galaxies, and the earliest moments of time. You may not see them, but they are always there, weaving you into the symphony of the cosmos, a gentle reminder that the universe is larger, richer, and more mysterious than your eyes can ever know. For so long, humanity believed that what we could see was the whole of reality. The stars in the sky, the glow of the Milky Way, the faint shimmer of distant galaxies seemed like the complete picture of the cosmos. But as we have looked deeper, we have discovered that most of the universe is invisible. It is made of hidden forces, unseen particles, subtle ripples, and quiet energies that surround us always. The visible is only the surface. The invisible is the vast ocean beneath. We have explored the quiet gravity of dark matter, the mysterious pressure of dark energy, and the endless rain of neutrinos that pass through us without pause. We have traveled to black holes, those silent wells where even light cannot escape, and to the rippling waves of space-time that carry the memory of collisions across the cosmos. We have drifted along the cosmic web, the invisible threads that stitch galaxies together, and wandered into the vast voids, the immense hollows of nothing that give shape to everything. We have felt the pull of magnetic fields, seen the hidden spectrum of radiation, and listened to the whispers of the universe's earliest moments still echoing through space. Together, these pieces form a truth that is humbling and beautiful. The universe is far more than what our eyes reveal. It is built upon invisible foundations, shaped by unseen hands, carried by currents too subtle for us to feel. We live inside this invisible universe every moment, part of it, woven into it, inseparable from its mysteries. There is something deeply calming in this realization. To know that the universe is not limited to the obvious, that there are layers upon layers of hidden truth, is to recognize that mystery is not a barrier but a companion. The invisible is not absence. It is presence in another form. It is the quiet breath beneath the stars, the hidden rhythm beneath the silence, the unseen that gives meaning to what is seen. Close your eyes and imagine it now. Imagine yourself floating gently in the cosmos, surrounded not only by the light of stars, but also by the invisible forces that hold it all together. Dark matter forms the scaffold around you. Dark energy pushes space outward. Neutrinos pass through you like silent raindrops. Gravitational waves ripple through the fabric beneath you. Magnetic fields weave lines of power around the galaxies. Invisible light shines across the spectrum, filling space with brilliance you cannot see. The voids stretch around you, vast and serene, while filaments connect galaxies like threads of a cosmic tapestry. You are at the center of it all, small yet connected, quiet yet part of the whole. The invisible universe is not separate from you. It flows through you, sustains you, and surrounds you. Every atom of your body was once part of stars that exploded long ago, shaped by invisible forces in their final moments. Every breath you take is carried by elements forged in the hidden furnaces of ancient suns. The invisible has always been with you, guiding your existence long before you were here to wonder about it. As you reflect on this, let yourself rest in the comfort of not needing to understand everything. The mysteries will always remain, and that is part of their beauty. You do not need to solve them tonight. You only need to know that you are held within them, supported by them, carried by them. The invisible universe is not something far away. It is the very fabric of your life, wrapping you gently in its silence. So let your mind soften, let your thoughts drift outward, beyond stars, beyond galaxies, beyond even the limits of light. Let them dissolve into the invisible, into the quiet currents that shape reality. You are part of it, safe within it, connected to all that is seen and unseen. And now, as you close your eyes and let sleep take you, know that the universe continues its quiet work. Galaxies spin, black holes merge, neutrinos stream, gravitational waves ripple. Invisible forces move through the silence, weaving the cosmos together. You are part of that great weaving, a single thread in an endless tapestry. Rest gently in that truth. Good night.